Welcome back everyone to another video, and in this one we are looking at this particular kit by Avnet. This is the Azure Sphere MT3620 starter kit. It's Microsoft Azure certified. Now I hope I don't come out as a Microsoft fanboy, and I've always come out as an open source fanboy, Linux fanboy, but this is interesting because this is the only SOC, the MT3620, that runs the Azure Sphere OS. And yeah, this is not FCC approved. Uh, and they had the FCC logo on the box, which was covered by this black tape. And it's not approved, and that's kind of the reason I think they gave away 20 or 200,000 of these. I'm not sure how many, and this is how I got mine. I'm not going to buy something that has Microsoft on it for reasons. And yeah, so it was very interesting because the Azure Sphere OS is Microsoft's operating system based on Linux. This thing runs the Linux kernel on it, but it's extremely uh, in a extremely closed ecosystem, as we'll see. And this is the only SOC that does that. So if you want to run Azure Sphere OS properly, you have to get this one. And yeah, so they were giving a bunch of these away. So again, the first one says it's not FCC approved. I think that's kind of the reason they gave it away. That they had a few lying around that didn't quite go through FCC, and they just thought, why not just give them away and people might use them. And again, special note, source code compliance team, Microsoft Corporation. Yeah, I mean, that's the weirdest thing. License note that says it's GPL and LGPL compliant by Microsoft. This is the like kind of the weirdest thing I've seen in my lifetime. The word GPL and source code compliance team, Microsoft Corporation in the same sheet. Like I have a physical proof of that. Amazing. Um, right, and that's where the fun ends for open source people, because you need to have Windows 10 computer running their SDK, which is based on their Visual Studio stuff, and that's the only way to do anything useful with this board. You want to flash it, you want to code it, you want to do whatever you want to do with this board, you have to have Windows 10 and Visual Studio Code running on it, and that is because of a bit hardware thingy that runs on it, and we'll go on in detail about it. Yeah, so Azure Sphere OS, it's specially designed for very limited resources devices that still need to run a proper operating system. So here's your board and some micro USB cables. So for in fact, this particular board has like 16 megabytes of storage and 4 megabytes of RAM, and that's it. So they have to design like an operating system that runs in that limited resources. So apparently Windows NT or the NT kernel wasn't good enough. They had to go the Linux route. And like it just stops at the kernel. I don't think there's anything else than the Linux kernel that is able, that any way correlates to the open source community in terms of the operating system that is running. So let me just zoom in a bit, see how close we can go. Right, so I'll go over some of the features on and stuff on this board. So on this board you have your two micro click expansion headers, and there are 2.54-inch headers as well. So you can just as well just add wires to it or jumper cables, or actually use the micro e-click boards. You have your groove sensor here, the groove connector here for I2C. You have 5-volt input and battery input. You have your micro USB for debug. This particular FTDI chips breaks it out to JTAG and 4 other UARTs that's connected directly to the SOC. And this is the enclosed module, so it has Wi-Fi regulation and stuff. So that's why it has the CAN on there, and dual band Wi-Fi antenna here for A, B, G, and N channels, and then two user buttons, a reset switch, 3-axis gyro on there, 3-axis accelerometer on there, a temp sensor, pressure and barometric sensor, and a photo and an ambient light sensor. So if I tilt this, and you see a little chip right there next to the groove sensor, shine, that's your photo sensor, or the ambient light sensor. Nothing on the back, just traces. uh, I personally like black PCB, just like from aesthetics, but people usually criticize it because the traces cannot be routed as easily, and there's usually an issue if you are if you want to see where a particular trace goes. um, but yeah, so that's that. I'm okay with it. People don't like it, it's fine. Yeah, so that's about the actual hardware that's on there, and the module I am going to speak about, which I have a lot to say. Right, so this is the block diagram of the SoC. It has a Wi-Fi, a pretty solid Wi-Fi subsystem. Um, the dual core Cortex M4 IO subsystem, and then your application process subsystem. It has a Cortex A7 at 500 megahertz with Neon and FPU instructions, so that's always good. And then it also has trust zone and stuff like that. So all the ARM goodness is there, and yeah, a bunch of GPIOs, PWM, UART, SPI, SQC, ADC, all in there. So a good healthy assortment of IOs. The thing that's bothering me since I've looked at this is the Pluton security subsystem. Now, this thing has its own Cortex M4 core. There. So apart from the two, there's a third one, and its job is only to provide security. Now, this thing does everything from booting the SOC, running in background while the SOC is booted. So it notices everything, what code is running on the SOC. So yeah, it's like UEFI but on hardware. And the problem with that is it's going to be very difficult to run your own non-Microsoft signed code on it, something that's not generated by the VS Code subsystem. Um, the VS Code environment, or running your own operating system that's not related to Azure Sphere. You want to run Linux, you want to run Zephyr. I don't think that's going to happen that easily unless you find a way to either break free from the Pluton system or have it sort of signed, fake signed it, and run on it. And unless the signature is approved by the Pluton security subsystem, it's not going to run. So like it's all gods, the whole security subsystem is a real-time SOC on its own. um yeah, so apart from that, no, nothing much. There is again, as I said, 4 megabytes of RAM, I think 16 megabytes of flash storage, and that's not much to it. The only interesting thing was the Pluton security subsystem. But yeah, a single core A7 probably just boots Linux, does the Wi-Fi, and runs Java stuff if it needs to, or JavaScript stuff. Not the same thing, of course. Or maybe some other services it needs to run, connect to Azure Sphere Cloud over that, and that's it. Just a very low power IoT device. The They probably would have gotten away with not using the um, A7 core and using like a M7 core that can run Linux, because they can very well run Linux. But whatever IP MediaTek had lying around to throw in a sock quickly enough. So of course you can't interact with it. You can get some UART output that I have tried, so I'll show you guys. But it's not going to be too fun, just a little bit. So I'll show what's going on at the on the UART side of things. Again, if you quickly just simply power it on, it just does a quick blinky light demo, and that's it. So I will take the official cable here, plug it in and plug it on into my Linux system, because you can interact, like you can see the UART output when it boots on the Linux as well. So you turn it on and it does this blinky thing, powers on, runs LED, and that turns red. Right, so I have the fourth USB channel on this chip set to 115200, which is kind of the standard baud rate. And when you press reset, that should pump out stuff related to Pluton, and which is actually loading images onto the SoC. So pressing the reset button, and there you go. So I think what's happening, I don't exactly know what it's showing us. So if anyone has details on Pluton, or knows where I can find like written documentation on this stuff, I would be very much interested to see how this thing actually boots. So I think it goes, it loads the bootloader, and this is probably the memory location where things are being loaded. And I see three signatures. So G is this one, and then D, and then the next one is N here. Now the interesting thing is, between reboots or resets, logging initialize, booting application core, and then that's when we go into Linux. Again, the Linux console is not here. I don't see anything. And while we are rebooting this, the first two signatures remain the same, the third one changes. So if I do a reboot, again the G stuff remains the same, the D stuff remains the same, but the N is an entirely new signature. So if you compare these two, and again on a third reboot, same thing happens, N changes again to a completely different signature, and again and again and again. So so, and probably whatever security thing they have, it generates a signature at boot. And I'm sad I cannot get a Linux console at all on this one, so not sure what this is running. I have tried uh, UART 1, UART 2, UART 3, UART 4, nothing on them. And I can try UART 2, nothing. UART 3, nothing. So not sure if I don't have the correct baud rate, or it's just like kind of a luck thing that's not working out for me. Um, Whatever weird thing they have implemented on there. The weirdness of Linux. Yeah, so I mean, let me know if you want me to start up a virtual machine and get into it, get a build running, um, try some blinky applications, hopefully get the Linux console to do something, at least to see what Linux version. Like we don't even know what Linux version this is running. Someone might know, but I don't. There's no proper documentation on the Linux internals. They just say, all right, this is running Sphere OS. Like you have to go deep down to see that Sphere OS is actually Linux. And then they say take the SDK, have a Windows 10 laptop, and you're good to go and write your application. Don't care about the operating system. uh, that's kind of, I don't know what else would you will you expect out of Windows, out of Microsoft. But this is what it is. So thank you everyone for watching this. And I will talk to you all in the next one, and hopefully with some better demos and stuff like that. Something that's a bit more interesting. Thank you so much, and hope to see you all in the next one.